Hi, this is Laptop Radio. Today we have Laurence Ion, and the topic today is how we can stop aging. Hello, Lawrence.
Hi,
Uh, let,
I'm glad to be here.
yeah, thank you. Let us know about your story.
I have been a tech entrepreneur. Although when I was young, obviously I wanted to to be a doctor, like many kids growing up in Romania. You either chose to be a doctor or astronaut or lawyer or something like that. But I was obviously, as most kids during this time, in love with computers and video games. And so I wanted to make my own video games, make my own websites, and so on. So I kind of started going in that direction. It was more fun, stuff was happening. Whereas in biology, um, the system was quite old. You had to remember many names, and they weren't teaching you like how to really understand how things work. So basically I just started a career towards just pure computer science, machine learning. I eventually gave up games. I kind of went towards building products, stuff that people would actually get useful things out of. Not that entertainment isn't useful, but it's I got more. It felt more impactful, to do stuff that is that has utility. So yeah, I did some startups. The last one was Intersect. It was a dating app for teenagers. You would see who you crossed paths with in the past, like during your day, and you could see a history of everyone you passed by, and maybe if you locked eyes and you smiled at each other but you didn't talk, you could kind of add each other as friends.
Yeah.
And and then we did some other software as a service tools, but eventually, I wanted to have even more impact. And this whole I was passionate about biohacking and um, kind of longevity in general, like just how can I be as healthy as possible to
Mhm.
extend my health span and not get to old age being sick, being miserable, suffering. So yeah, I
How were you, like what, like when we think about longevity and aging, that's just so different from gaming, and that's so different from biology, right? I mean, when people focus on
dating apps.
yeah, when people focus on biology, they think, oh, how do we cure cancer? I mean, I remember when I was in college, I was really in biology, molecular cell biology,
Hmm.
at Berkeley, and my goal is actually I was pre-med and before I became a lawyer actually,
Hmm.
and I wanted to find a cure for cancer, but I don't think about, oh, how do we stop aging, right? So what
Yeah.
is that in you, that wants to help stop aging?
Well, so a few things that I want to mention. First of all, with cancer, um, you know, actually, so you have these big killers. Cancer, heart disease, diabetes, Alzheimer's, and lung disorders. They're the biggest five, and they grow exponentially with as you age. And so, even if you do cure cancer, um, the average lifespan on the planet would increase by only about 2 years, because the other diseases, all of them are going exponentially, right, at the same time in parallel. So the other ones would catch up. So you'll die shortly of something else. So it doesn't have as much impact. So I was looking at that, right? Because of course I wanted to cure cancer as well. um, and also the other thing to mention here as a small, maybe we'll get back to it, but medicine is doing it wrong in a way. At least with cancer, we know we should detect it early, but
Mhm.
we don't do anything preventative. We don't try to fix the mutations that appear in the nucleus that eventually cause to cancer. We don't try to kill the senescent cells. Many things like this. And so basically we wait until people get these diseases. with cancer is a bit special, but the other ones like Alzheimer's and heart disease and so on, we just wait until it's bad enough so that we do interventions, and that's the wrong way to go.
Mm-hmm.
I'll get back to that later, but to continue on why, what was the other question though? Why aging instead of cancer?
Yeah. Why aging
Yeah,
is cancer?
yeah. So I believe in this technological advancement. So basically, of course, our life expectancy has been increasing steadily over the past few centuries, from like 40s in the 1600s to 85 in the 2000s. But that's mostly due to antibiotics.
Mm-hmm.
People used to kind of gather around their child's deathbed and watch the child suffer, slowly being consumed by bacterial disease. And I think zooming out in the future, we will look back at this age and think, we didn't have anti-aging therapies, and it was barbaric. We just let these beautiful wise people, elder people, just rot away from the inside from aging, cellular degeneration. So I want to fix that as a cause of all of these diseases. It's not like you have these diseases like infectious diseases, and then we have, the genetic disorders, and then we have the third category, which is like these age-related diseases like Alzheimer's, Parkinson's, dementia, so on. But then there's completely different thing here in the fourth category called just, aging. You're like frailty and like muscle loss and lost vision and so on. Like, no, they are actually the third and the fourth category, the Alzheimer's and the sarcopenia. They're all caused by the same thing, the cellular degeneration, the damage that accumulates. And if you fix the cause, you fix all of them. It's just that some of them we gave names to, and the other ones we just call people are old.
Mm-hmm. What do you think about like for
Yeah.
longevity? What do you think about so from a biology perspective, um, people have lifespan, right? A lifespan of a deer, a lifespan of a carrot, a life a lifespan of a fish. They're completely different, right? And then you have a lifespan of a human. Um, and when we're talking about population, a lot of cattle might not survive during birth, and human, their lifespan the chart looks completely different from fish, carrot, and deer, right, or cattle. So what do you think, if the lifespan of a human is longer, what else do we need, for vitality and the like? So we're not just expanding the life of a person, but if they're like 70 years old or 80 years old, yet they could not
Yeah.
function, then that's different, right? How do we actually ensure more of a balanced life, not just lifespan, right?
Yeah. So of course, I I'm I try to be careful with these things, because a lot of people think that we're just trying to extend life and just keep older people in a poor state of health for longer, which is exactly the opposite. I mean, that's what the medicine today is doing. Of course, doctors are trying to reduce suffering and prolong life, but they are being reactive. They just and so many billion-dollar drugs that are just made to ameliorate and manage symptoms, and that's what they do. They keep people in a poor state for longer, poor state of health. And so yeah, we do want to just increase the healthy lifespan, uh, or health span, right? And then as a side effect, you live longer. But there's a certain thing we call longevity escape velocity. We don't think we're going to have a breakthrough now and just basically make people live to 1,000 years, but we can fix the damage and add some healthy years. And then
Mm-hmm.
in those years, as you age, therapies get better. Technology is advancing exponentially. So let's say, in 5 years, we can rejuvenate you by another 2 years, and then another 5 years, maybe by another 4 years, and then in 10 years, another 10 years. And then basically, you every year we extend the health span by more than a year. So basically, you just live indefinitely as far as we can tell. Of course,
So
there's
Lawrence, what
no
do you?
guarantee, but that's why I want age to work on aging, right?
Yeah, so just to connect with that, what are you working on now in the aging space? And of course, I do know. And I just wanted to make sure that the audience know like who you really are, what kind of company are you with, and how are you working with the Asian space since we're talking about this topic.
Yeah. So until now, I've been researching a lot. I've been learning. I was super passionate about biology when I was younger, and I was, going to like the Olympiad and like the national competitions and so on. But then I kind of let it behind. So I had to learn stuff like biochemistry and
Mhm.
genetics again. And of course, by the way, like regarding the animals, I can talk about some therapies we did and some successes we had, but there are actually animals like the bowhead whale that live to 200, or the Greenland sharks to
Yeah,
400, or some fishes, some um, turtles don't appear to age at all.
yeah.
Maybe they just age so slowly that this is not noticeable to us. But yeah, regarding to what I'm working on, first of all, I'm keeping an open mind to explore as where can I have the biggest impact, because it's a mission driven thing. It's not a certain company or so on. So I'm collaborating with some labs. I'm helping as a volunteer. I am uh, giving speeches, so advocacy, I would say. And also I'm organizing a conference on longevity in Oxford with a friend a friend of mine, Dr. Avi Roy, co-founder of BioViva.
Hmm.
And so this is going to be a completely different type of conference, a collaborative one, um, where we incentivize people from multiple disciplines, even physics or inorganic chemistry. These people, they start realizing, hey, I'm aging and there's this thing, longevity. I don't know how to contribute, but maybe I'm going to this conference, and the aging labs, they can present the projects, and not only the successes, the finished projects, which happens usually. We want them to show what's going on, where they're stuck, and maybe these people can come up with ideas, and we match make them so that we bring the field forward.
That sounds awesome. I think it's kind of important to talk about it because I think, I mean, aging is longevity is very interesting too. Um, the population, I think, generation has changed, right? So if you actually look at biology, it's different for every countries as well, and it affects basically how the countries are run, offsprings, and also economics, right?
Hmm.
Um, and I also think that if people are living longer, how do we prepare for that?
Yeah, so there's many things. We will have a lot to work on for sure, but
Yeah.
so like the biggest example is people talk about overpopulation, right? But in reality, like population numbers are driven by birth rates, not death rates.
Yeah.
And they had a gathering in the 1960s in Rome, where they were like, "What are we gonna do by the year 2000? We're gonna eat each other," right?
Yeah.
They didn't account for technological progress and how we manage resources and agriculture and so on. So I don't think it's that big of compared to. So look, aging kills 100,000 people per day. Um, that's 3 million per month. That's 36 million per year.
Hmm.
Compared to that, it's hard to say that anything else compares. And we will eventually, of course. So um, let's say we do cure aging after a long time, like we're not just going to cure it now, right? We just
Mhm.
prolong the life and the health span, and stop keeping people in a poor state of health for longer. That's the biggest thing, short and medium term. And let's say eventually, yeah, we do cure aging, and by then we will definitely manage researchers much better, get them from asteroids, be on Mars and so on. And I'm sure invent 3D printed meat or lab grown meat that is scalable. We already have some of these technologies, but maybe they're not scalable. And the other thing, once if you look at any country, the developed countries, when people have higher life expectancy, better quality of life, healthcare that is good and working. Um, I mean, it's debatable in the US, but I mean, like, it's actually, effective, even though in the US it's a mess with the whole expenses stuff. But,
Mhm.
clearly, birth rates decline, and the population in the developed countries is declining. And the growth right now is coming from the developing countries. And once you cure aging, people are not going to have as many kids as they do now. And also, a part of aging is women's um, inability to make kids after a certain age. So there is a, exponentially declining after 35, right, or
Yeah.
40s. And I mean, we're getting better at that, but eventually we will fix it. So women will just choose to have kids later and later. And I mean, imagine living 100 years, getting all this experience, and then having a kid. Or some women will obviously realize that maybe they don't actually want a kid, because that's a big problem where people or women decide to, because of the pressure, because
Yeah.
they're turning 35 or 40 or so on, they just decide to make a kid, and maybe that's not the best for them or the kid.
Yeah. I mean, there's a concept in biology, right, that, is basically care distribution.
Mhm.
um, and, if you produce a large number of offspring, your energy investment in them is relatively small.
Yeah,
Um, so you don't usually provide a lot of parental care, right? And
yeah,
then the offspring is on their own. However, if you produce a small amount of offspring, then you can provide them with more parental care.
yeah,
So that with that concept, it's wiser if you, especially if you're older, to have a small amount of offspring, right?
yeah. And also, definitely, a lot of people talk about, the fact that the old has to die so that they make room for the new. But that's clearly, I mean, imagine having Einstein and Steve Jobs still alive, and these. It's quite a shame that when people can actually start contributing to society, maybe after their 40s, when they've learned enough and they can actually do things, their health starts to decline, so their productivity will go down. Or you have someone who's reaching 60s and they're thinking, well, I'm close to retirement, even though technology is advancing, and maybe they should change careers and start maybe programming or whatever.
Yeah.
They're like, I'm just gonna be old soon, I'm not gonna be able to do it anymore. And they just don't dream higher. And also, like, actually, let's say, um, instead of spending all this money in the US, like $4 trillion in a president's term, which is gonna that's basically where it's heading.
Yeah.
Instead of using that money for palliative care for elders, we could just fund people in middle age to take a 10-year sabbatical, travel, do whatever they want, change their careers, because they have the the next part of their life, and the next one, and the next one, and so on. So yeah, I think every
Yeah.
4 years we could just finance this, so people change their careers.
What do you think? What do you think? Like, based on longevity, do you think that it would affect the age sex structure for human, right? So do you think that it will be faster growth? Do you think it'll be more stable? Or do you think it'll be more like shrinking in terms of like male and female?
I actually have never thought about that. I don't know if so. I always thought like people, right? I don't know what is the difference between women and men regarding aging.
Yeah, I mean, I'm just, I'm just kind of curious, right? I mean, sometimes, a lot of people say that females live longer
Well, yeah, they do,
than
but
male, right? And like the rapid growth is like from they grow a little bit faster as well. Like, but in when guys are
yeah,
about junior high and high school,
yeah,
they grow a lot faster, right?
yeah. True,
Um,
true. Women
so
develop much sooner.
yeah, I think that research is going to be really interesting. How does like longevity impact, age sex structure for humans?
Well, so again, like population is driven by birth rates, not death rates. But if so, anyway, if we postpone this period of ill health at the end of your life, and we postpone it indefinitely, basically, just everyone is going to be alive. So what matters is what people make. Do they make girls or do they make boys? But regarding the whole women live about 7 years longer than men, I haven't looked into this recently to actually, because you have to do a multivariate analysis. You can't just look at that because it might be, if you look at an average lifespan or life expectancy,
Yeah,
well, maybe men work some jobs that are more dangerous, or they die of accidents or stuff like that, right? So that's included into the 7 years. um, so
yeah. So
you
so
have to
that's,
isolate. You have to look at people the same lifestyle, maybe, or the same nutrition, the same social condition, maybe, the same social status, basically.
yeah. So let's go really just go back to the basics of survival.
Hmm.
So survivorship curves shows what fraction of a starting group is still alive at each successive age, right? So for a sheep, they basically, when they're like really young, there might be 1,000 of them, but when they're like in 12 years, they basically, most of them die, and that's their lifespan, about 12 to 13
Hmm.
years. For humans, we're like type 1, right? So we grow, and then at 100 we basically kind of go down, right? um However, I think trees, there's a lot of seeds, but they kind of live and stay forever, right? Birds are kind of different.
Yeah,
So
well, with
how
trees,
are we
it's quite different. Yeah.
yeah, how is it different? Maybe you can talk about it. There are types.
So I read about this quite a long time ago. I don't remember all the details, but it's completely different the way it works. I mean, with trees, you can say like they die every autumn and they get reborn, and there's some species of jellyfish that do this as well. They kind of die and respawn, so basically they live forever. But it's not. Is it really the same organism? It's hard to tell. Like, we couldn't do that. We couldn't just like disintegrate, because we would lose our memories, our personality, ourselves. It's hard to tell for trees and jellyfish.
Yeah, yeah. So just wanted to go over just basic stuff. So type 1 humans and most primates have a type 1 survivorship curve. So that means that we as humans tend not to die when we are young or middle age, but we die when we become old. And we tend to have
Hmm.
small number of offspring, and then we provide lots of parental care to make them survive. And then, but
Yeah.
birds are type 2, and that means that they die more or less equally during the whole period. And they have relatively few offspring, and they provide significant parental care. So you see birds feeding their little smaller birds. That's the reason. And then you have trees, and they're usually type 3. They're usually most fish and
Mm-hmm.
people and stuff that live in the ocean. So with them, they survive. Only a few survive when they're younger. But the lucky ones who survive live longer lives after that. So and these
Yeah.
types of species, they have lots of offspring all at once. And they don't really provide much for the offspring afterwards. So they're more independent, right?
Yeah.
So if we're basically changing longevity for humans in that type 1 survivorship curve, I was just wondering, how that would look like. So will we become like birds? Where we basically
No, we just
care all throughout, longer lifespan, or we're gonna be like, I guess we won't be like trees because we would survive. You know what I mean? Like, because our offspring will survive,
right.
and and
Yeah.
and the whole concept of changing that birth, life cycle. So in
Yeah.
right, like it's
So
called internal parity, right, where people can basically reproduce throughout their lifespan. So will we be doing that when we can actually give births? Do you think that would affect biology like that, or will evolve into that?
so super long term is hard to tell. Even if we don't know what's going to happen super long term. It could be a singularity, right? We could be
Yeah, that's what
merging with the AI and start being that digital consciousness traveling among the stars between computers, or this just have these huge computers as big as stars or
then we
so.
have like CRISPR kids, right?
Well, I don't even think eventually will be biological, but because it's not the most efficient. So but getting back more to medium term at least or something, aging is caused by physics, not biology, right? So there's just like a car, parts wear down from all the rubbing and grinding, the metal rusts and so on, right? So our bodies as well, they have these trillions of tiny physical processes, and you've got the oxygenation, you've got the radiation from the sun and the cosmic rays and so on. And we do have mechanisms to repair this damage, but they get less effective over time. What we're doing is kind of trying to Dr. Aubrey de Grey has this good explanation. Like, you have metabolism, it causes some damage, and then the damage eventually, when it accumulates, it causes pathology. So what we want to do is just fix the damage, maintain it, just like we do with a car.
Yeah.
Uh, and so, I mean, nothing is really going to change. Imagine with HIV, for example. It's not, we didn't cure it, but we do postpone we have these drugs, right, that just postpone it, and you have to take the drugs all your life, but you never die of HIV anymore.
Yeah.
So I think the same with aging. We're never going to really fix it because it's physics. It's just entropy. It increases all the time. There's always going to be damage accumulating. You just got to keep treating yourselves with these therapies, doing this maintenance.
You don't think that stem cells would help though? Like, if we can
Yeah,
regenerate
of course.
cells
I mean, that's
continuously grow, then we might not age, right?
No, so stem cells is one category of so there's these so
Can can,
there's
can I ask you
Dr.
about
Aubrey de
the
Grey also.
vampire blood as well?
Hmm?
You know how like billionaires are said to
Yeah,
blood from younger
yeah, yeah, that's a bit controversial, but I
people?
mean, there's some things that happen there. There's some biomarkers that improve, of course, but so Dr. Robert De Grey also, he's the chief science officer at the Science Research Foundation, and he does great advocacy. But so about 2 decades ago, he made these 7 categories of damage, and yes, one of them is the cell loss and cell atrophy, and you replace these cells with stem cells. But
Yeah.
there's others, there's of course the death resistant cells, senescent cells, and you have to use suicide genes to tell them to just disintegrate, because they're preventing other cells from replacing them and doing their job, and they're releasing these chemicals that are bad for their neighbors and so on. And you have like the intracellular junk and the extracellular junk that accumulates, and extracellular matrix stiffening, and the mitochondrial mutations. You can just take the mitochondrial RNA and back it up in the nucleus, where it's like this bombshell that keeps it safe.
Yeah.
And you have also the division of obsessed cells. You've got the nuclear mutations, which eventually leads to cancer. So yeah, there's not just stem cells, but all of these 7 categories. We have a lot of therapies going to market. I mean, none of them are yet available that you can just like say for sure you can take this and you're gonna be younger.
Yeah.
Also, even if you take a few of them, it doesn't help. You have to take all of them, because if you don't die of something, you'll die of the other, because they're all going in parallel exponentially. But yeah, there is a huge progress. There's unprecedented actually advances in recent years. It's become an industry now, the rejuvenation, not just a field. And I'm not talking about cosmetic rejuvenation. It's the Leaf Foundation, the Lifespan.io have this roadmap, which shows there's companies that like, maybe I shouldn't name names, but there's companies in phase 2 and phase 3 human trials, and once they pass these, they will go through approval and eventually get on the market. There's some that are not so advanced, maybe just phase 1, maybe preclinical, in vivo, in vitro, who knows. But it's actually hard to keep up. I have no idea which ones are. I have to look at the roadmap again, because it changes all the time.
And then, and I'm also curious about the process of cell generation, mitosis versus meiosis, and um, for for reproduction of human beings, and and not just the cell, right? So I think for both processes, do you think there will be a third process that would evolve somehow, that would mix some kind of AI or some kind of genetically modified process to a more natural process? Do you think that would combine a hybrid model, that process that the body would basically, because I think the human body is amazing. Do you think
Yeah.
it would come up with a process that regenerates, putting together artificial processes and elements into more the biological ones?
Yeah, so I mean, obviously we'll get to this. First of all, first of all, I think that anything that is not against the laws of physics, we will be able to do, especially with quantum physics. I mean, if we can just have the power of the quantum world, we can just basically do anything that is within the laws of physics, of course. But yeah, we are already cyborgs. We are not just our biological machine. We are definitely interconnected in the cloud, and we have this iPhone or Android or whatever phone in your pocket, right? And you interface with it with your thumbs, and you have a digital identity, and yeah, of course, any information is just at the fingertips. You can just Google anything, but it's a bit slow with the fingers. But if you could just so like from your brain to the internet, it's hard. It's this bandwidth that is limited. Um, but if you could have a brain machine interface to make this bandwidth a bit higher, for input is not a problem, because as long as you can, let's say, think and just Google something, then you can have the visual. You can have like some AR glasses or something that just shows you you have a lot of bandwidth, a few megabytes per second or whatever, watching HD movies, right? That's a lot of information coming into your brain, just coming outside it. That's a big problem. And you know once we have this much higher bandwidth, Um, will we be the same? It's hard to tell.
Yeah.
It's we will be able to communicate at the speed of light, basically at the speed of thought, maybe,
Yeah,
without
I mean,
speaking. It's going to be much easier to kind of be connected, and the individual might be lost in a way, but it's yeah, you can't really predict. It's a sort of a singularity thing at that
yeah,
point.
but when you really think about it, the process of mitosis, right, is asexual
Yeah.
regeneration. So, but yet now we have stem cell generation, right? So things could basically
Hmm.
process by itself. And then we have meiosis, which is really fertilization, and it ensures diversity, right? That everyone who is born is really different. But when you really think about artificial intelligence and computer stuff, they're
Hmm.
similar, right? They're designed to actually have, to do
Exact copy.
exactly. So you have the process of meiosis, which is really its mission is for to generate genetic diversity, and then you have computers and AI that does exactly the same thing, right? So
Yeah.
and
Is-
not just. Like for me personally, would that mitosis meiosis process, would there be a third process that adapt, the replication part, how it works, and have that equator and how it generates and become one, it explodes and then two cells split, or and you know what I mean, like, or does it, or does it
yeah.
does it, like, when it does that, does it incorporate some of the AI stuff, and so that ensures genetic diversity, but at the same time have that duplicate, and it gets, it kind of uses right hand and grabs something from that computer chip and incorporate it in that, meiosis or whatever name that we will call that process later on, right? That, something hybridosis or something, right? You know what I mean? Like it
Yeah.
has to be different.
Yeah. It's hard to tell what's gonna happen, really. I mean, obviously we're gonna have to have some sort of a decentralized system, and of course diversity is good. And yeah,
I
so
mean,
I
like,
mean,
so we're gonna use a blockchain, a genetic blockchain in the system, right? That
yes, for
nano,
sure.
it would be,
Once,
a
yeah,
nano blockchain, basically,
there's
in the cells
there's
with
no other way for
information.
a safe, yeah, there's no other way for a safe future if you have AGI controlled maybe with a brain machine interface or not. It's hard to tell, but if it's controlled by just a few people, then it's game over for everyone else. I mean, they can't catch up. So you do have to have an open source, decentralized and democratized, so basically anyone, everywhere, anywhere can kind of vote on what this AGI will do. Hopefully, maybe with their brains, but because you do need to have this higher bandwidth.
But let
But
me ask you a question though about not just AGI, but hereditary information that is in the DNA. Can they when once we have that information of person A, and then we add to person B, I mean, couldn't it just kind of generate by itself?
um, what do you mean?
Well, when you really think about it, right, our DNA, the helix,
Yeah,
that
everything.
it's kind of like a blockchain. It kind of, like it has, information of person A and then has information of person B. And it has all the elements that make up all those traits, right? And we have to basically do math to figure out, oh, where does my widow peak come from? Does it come from my mom or dad, right? How
Sure.
come I have like brown eyes instead of blue eyes,
Yeah,
right? And, of course, some traits are dominant and submissive,
yeah,
but those
yeah.
are all, could be calculated, right? So if we have a blockchain or some kind of future blockchain that could be named differently in the future, that is, has that kind of DNA information, but at the same time, it could be kind of self-generated by itself, right? Because then some of these information by people are known, right? So say you have your DNA already, and then I have mine, right? And then later on, like person C and D comes on, and those informations are there. So every single generation of that is different, and that in the nanotech, biological DNA, that in the future, we could probably have something in there in our bodies that do that, so that when there is fertilization, we could basically grab either our human DNA from there, and then also grab some kind of like storage files from like from an interplanetary filing system, that is more biological based, right? So that is
Mm-hmm.
more AI stuff, right? So that we can combine and do that process. So like AGI, we have training, but I guess a computer and an AGI could do that. But mixing that with the tracking, right, of our genetic data or the DNA, might be interesting.
Yeah, and it's not only about the genetics, the DNA. It's also, you've got methylation, you've got, so expression of those genes matters a lot. The epigenome, as we call it, right?
Yeah.
Um, so not all of your genes are active,
Yeah.
and
Yeah, and they communicate, and the cells communicate with each other as well. So I mean, the system just has so many factors, I think, and sometimes when one thing changes,
yeah, it's fascinating.
yeah. So
Yeah,
it's super, super fascinating. So
yeah.
what is your like vision? When do you think that it will become like everyday material, like that fountain of youth, right? Like,
Yeah,
like now the billionaires can buy blood, right? Or stem cells,
yeah,
like,
that's part of it, but it's not, I wouldn't say it's enough. It's clearly uh not there yet. I mean, yeah, of course you can have some therapies. You've got Liz Parrish, who which is the CEO of BioViva, and she did two gene therapies on herself, extending her telomeres so you don't get senescent cells anymore.
yeah.
So with telomerase, this enzyme, and also the one which made her stronger, so preventing sarcopenia basically. But yeah, of course, I mean, you can just, I mean, you need way more therapies. But then, of course, you can also use stem cells. You can save your stem cells now. There's companies that do that, and it's like a banking system where they keep them cryogenized. So basically, you can use them later when you don't have as many stem cells. That's a big problem because you lose the stem cell population. So basically, at that point, there's nothing that can repopulate your cell population. But about when, I don't know. I think so. That's what I'm working on, right? Like making these happen faster.
Yeah.
There's no way to know how these human clinical trials will go. But the thing is, it's happening. About 10 years ago, we had none. Uh, or at least not that I know of. I mean, I was very young back then, but I think, you know, I was speaking earlier with epigenetics as well. I think there's a lot of advancements.
Mhm.
And also, as I said at the beginning, when I was younger, I thought, biology is this old system. Nothing is happening really. It's not fun.
Mhm.
And I kind of accepted aging as inevitable. I mean, it makes perfect sense psychologically to just put it out of your mind because you're just taught it's inevitable and it's bad and you'll be sick and die eventually. But actually, biology is a mechanical technological system, and with technology advancing, we can hack it. And turns out it's feasible. It's very feasible. And then once I looked into actually studying more now, with what we know now and how these online courses and courses at universities and books and so on, like it's actually really really fun. I am literally in awe when I learn about this stuff of how
Yeah.
our body works.
Yeah,
And
I love biology too. It's amazing. I'm
yeah,
very inspired by your work.
Thank you. I hope I'll do. I'm planning to clearly work as hard as possible to advance this. To make a dent. Use all my resources, all my
Yeah,
um,
you having a great team.
relentlessness. Thank you.
Yeah, you guys have an awesome team. So
Thank you. So yeah, I think many more people should think about this project. It's the most important project. I mean, not only that 100,000 people die per day, but you got to think like the difference by one day. Yeah, of course, it can cure 100,000 people, but what if it's 3 years this gets solved? So it will determine which side of the chasm you'll be on. So I think everyone should try to contribute and help. And imagine like you have two options, right? You can work on curing aging as a project, or you can work on some other random fun project. And then that's the option two. And then option one, after you have cured, or we have cured aging, you can do another random fun project. Whereas option two, you're dead, right? And then option one, you can do another one, and then another one, and then another one, right? So whatever you think is more fun. First of all, I don't think I really think this is really cool, really fascinating. But yeah, you can definitely do so many more fun things if you cure this first. So I think it should take priority.
yeah,
Yeah.
so um for for now, um what kind of advice do you have for, you know, just you and me, normal people, right? To prolong our life and stop aging? I mean, is it the sun? Is it food? Is it exercise? You know, what do we need to do to stop aging today?
I mean, yeah, so it's clearly um, a big thing working on being healthier, right? Eventually, we're going to do these therapies, but until then, you've got to make sure you're going to reach the point where these therapies are available and you reach longevity escape velocity. So you've got to just do your best. I mean, it's really hard to tell with nutrition, for example. I've studied it so much, but it's such a hard thing. Like epidemiological studies, there's mostly irrelevant in my mind because come on, you can't, it's mostly correlations, and also you can't trust what people say. And like, for example, saying that um, meat is or like red meat and processed meat causes 18% more colon cancer. I mean, that's really hard to say that because you can't isolate it. People who, they're told that first of all they're putting them together, so maybe red meat isn't so bad, but it's combined with the processed meat. And people who eat this, even though they're told that it's bad, they're probably smoking, they're probably not exercising, they're probably not taking care of themselves as well. So it's really hard to tell with nutrition. But lately, yeah, we've had some cool research. I mean, it's worth looking into some things, but I can't really say this is longevity science. I'm more focused on the actual therapies to fix the damage.
Yeah,
You can look into ketogenic diet, you can look into fasting, or you can look into stuff like that, right? You can do
but we
things
have to
like
wait.
eat more broccoli, eat more broccoli sprouts, do saunas, do exercise, there's many things. It's hard to tell which ones are just correlations.
Go
It's
to the
hard to tell
spa.
causality.
Don't work.
uh, I mean, you've got like you see that people who walk more steps, that they do better. But is it because they walk more, or is it that the kinds of people who walk more, they're probably doing other things to be healthier and more active and so on?
Yeah, that's
I
true.
mean, yeah. So like, clearly, don't be sedentary. But maybe if you are and you do a lot of saunas, maybe it's not a bad thing because you get the same. But I don't know. Like, see, like it's. I'm just saying maybe, and I'm not even. This is not a scientific advice, but yeah, I mean, do your best, do your research.
And
Also, preventative things are very important, right? Like, do
yeah,
There's companies that can scan your whole body and screen for cancer. And you, yeah, I mean, the traditional hospitals don't do this unless you actually have symptoms, which is a shitty, shitty thing. Um, and now they're getting so much cheaper, right? Like $1,800 for your whole body scan with
Yeah,
using, AI and so on. I mean, a combination maybe of AI with doctors,
that's
because
great.
AI can be really effective. Like it can tell you the confidence levels, and like if it's really confident, then you trust it. But if it's not, because a lot of times it can give you a prediction, but it says my confidence level is low. So then you have a radiologist look at it, and I think that's fair. I think it's great.
And if people wanted to find you, where do they go?
To find me,
LinkedIn or
I mean, so yeah, LinkedIn, just Laurence Ion. I'm maybe in a podcast you can write my link there. I mean, I've got Twitter, LAUR_ION. I've got Instagram and Facebook. I mean, I'm pretty easy to find, I think. So
awesome.
yeah, I'm happy to talk to people. Any idea is welcome. Any help, anyone who wants to join this is a war against aging, and I want more people to help, because this is a high impact thing, and it's you know you can help in many ways, like either bringing money and attention by donating and investing, or just spreading the word in the press, social media, even at your dinner table, or doing the research itself. Or so
Yeah,
even if you're not in this field, you can help with AI, right? Like we need people in AI to join and help the labs or on longevity, or you know physicists and inorganic chemists, and anyone with their expertise can bring new stuff to the field and help. And
that's
yeah,
awesome.
I think everyone should
Yes,
join.
yeah, that sounds awesome. I think aging matters, and not just prolonging life, but ensuring that emotionally, physically, mentally, and dynamically that we are strong. So I just want to thank you for your time, Lawrence.
You're very welcome.
Bye bye.
Bye.